Strict traceability protocols ensure that every arriving shipment is documented and verified before entry. The journey begins here, where tons of raw, dry tamarind pods arrive from the harvest.
Precision starts at the gate, ensuring every kilogram of raw material is accounted for.
Once verified, the cargo is cleared for the unloading docks. The logistics of a modern factory rely on seamless integration between transport and processing. Inside, the raw tamarind pods are packed tightly, preserved in their brittle shells. Quality control checks for moisture content and pulp density before acceptance. Heavy machinery takes over the heavy lifting, maintaining a steady flow of material.
Each pallet carries hundreds of kilograms of raw potential.
We move from the chaotic exterior to the controlled environment of the intake zone. Before processing can begin, the raw material is staged for the initial feed.
Workers prepare the pods for the first mechanical stage of the operation.
The hard, brittle shells create a deafening cascade as they enter the system.
Vibratory motors ensure a consistent, jam-free feed rate onto the line.
Initial visual inspection removes large field debris that could damage downstream machinery.
From here, the material moves to the holding silos, awaiting the delumping process.
Before processing, the raw tamarind requires a controlled environment to maintain its acidic properties.
Automated distribution systems route the incoming harvest to specific storage cells.
Here, the pods are buffered, decoupling the harvest schedule from the production line speed. Digital monitoring ensures precise inventory tracking and prevents overfilling. Temperature and humidity must be strictly regulated to prevent mold growth on the sticky pulp. Periodic sampling confirms that the stored material remains chemically stable. When production demands it, the storage silos release the raw material into the active line. Because tamarind is sticky, mechanical agitation is often needed to maintain flow. The material leaves the static storage phase and begins its transformation. Safety magnets remove any tramp metal picked up during harvesting or transport. We now enter the main processing floor, where hygiene standards intensify. The pods are elevated to gravity feed into the mechanical breaking stage. A final cleaning step removes loose dust and shell fragments before crushing begins. Human oversight remains the final fail-safe before mechanical intervention.
The pods are now ready to be broken, releasing the valuable fruit trapped inside.
The delumping unit uses kinetic force to fracture the hard outer shells without pulverizing the seeds. This mechanical agitation separates the tightly packed fruit from the brittle waste material.
Powerful vacuums immediately remove airborne shell dust to keep the downstream product pure.
What exits is a rough mixture, stripped of its protective shell, but still holding the seeds. Human touch confirms the machine has successfully loosened the fiber and seeds. Because the pulp is naturally sticky, augers are used instead of belts to prevent clogging.
Monitoring the motor load tells us the density of the incoming raw material.
High torque is essential to keep the viscous, seed-heavy mass moving without stalling. Gravity assists in transferring the broken pulp to the soaking stage preparation. The material waits here briefly, ensuring a continuous feed into the hydration tanks.
Nearby, the thermal systems are primed to deliver the hot water needed for extraction.
Biochemical catalysts are prepared to assist in breaking down the pectin during the soak. The vessel opens, ready to receive the dry pulp and begin the hydration process. Hot water is introduced first to create a cushion for the incoming solids. The dry phase ends here, as the tamarind is submerged for deep extraction. Hydration is the key to unlocking the soluble solids from the fibrous pod structure. Mechanical agitation prevents sedimentation and ensures the water reaches every particle. Pectinase enzymes are introduced to break down the cell walls and release the pulp. Indirect heat is applied through the tank walls to activate the enzymes without burning the product. A precise thermal window is maintained to optimize enzymatic activity. Over time, the hard pods soften and disintegrate into a pumpable slurry. Operators verify that the pulp has fully separated from the seed and fiber.
The consistency confirms that the batch is ready for mechanical separation.
Gravity and pump suction work together to evacuate the vessel. Specialized pumps are required to handle the seeds without crushing them further.
The slurry travels to the separation deck, where the waste will be removed. We move to the separation phase, starting with the removal of the heavy seeds.
Pressure controls ensure the feed rate matches the machine's capacity. This trio of machines will progressively refine the paste, removing solids by size.
The first stage targets the hardest elements, removing the tamarind seeds to prevent machinery damage. Centrifugal force separates the heavy density seeds from the lighter, fluid pulp. With the seeds removed, the material is instantly transferred to the pulper for fiber removal. Here, the slurry is forced through a 3 mm sieve to catch coarse fibers. Rotating paddles press the soft fruit through the mesh while ejecting the tough skin and stalks. The waste material is collected for secondary use or disposal, leaving a cleaner paste.
The final refinement stage uses a tight 2 mm mesh to polish the texture.
Only the finest particles and soluble solids can pass through this final barrier. High centrifugal force drives the paste through, ensuring maximum yield from the raw fruit. The result is a refined, homogeneous puree, free of all physical impurities. The transformation from rough pod to smooth liquid is now physically complete. Efficiency is measured by how dry the waste is. Wet waste means lost product.
This buffer tank holds the refined pulp before it enters the thermal processing stages.
Continuous operation requires redundant machines to allow for cleaning without stopping the line.
The refined paste now travels to the thermal section for sterilization and concentration.
The refined paste must now be heated to prepare it for the final high-speed extraction. Tubular exchangers are used here to handle the viscous paste without fouling the surfaces.
Saturated steam is injected into the shell, transferring thermal energy through the steel walls.
The target temperature is strictly controlled between 85 and 95 degrees Celsius.
This thermal shock lowers the viscosity of the paste, making it more fluid.
A holding section ensures the product stays at peak temperature long enough to pasteurize. Consistent heat is vital. Any drop in temperature triggers an automatic flow diversion.
spent steam turns to water and is efficiently removed to keep the heating cycle efficient.
As the paste heats, internal pressure builds, requiring constant monitoring.
Heavy insulation protects the workers and prevents thermal energy loss.
Heat has successfully reduced the thickness, preparing it for the turbo extractor.
Redundant safety systems prevent overpressurization during the heating phase. The entire piping system is designed to flex and move as temperatures fluctuate.
Reaching the upper limit of the target range ensures maximum sterility and solubility.
Now hot and fluid, the paste enters the turbo extractor for the final separation pass.
The turbo extractor operates at significantly higher speeds than standard pulpers.
This intensity generates the centrifugal force needed to strip the last remaining solids.
The heated paste is instantly accelerated, thrown against the internal micro-mesh screens.
Friction and speed work together to pulverize soft tissue while rejecting hard fiber.
Precision balancing is critical. Any imbalance at this speed would be catastrophic.
The efficiency is evident in the waste. It is almost completely devoid of moisture.
This ensures maximum yield, leaving nothing valuable behind in the discard pile.
The output is a highly refined paste, now free of even the microscopic impurities.
The texture is now perfectly homogenized, ready for the concentration phase.
Digital tracking measures the exact volume of refined paste moving to evaporation.
Back pressure is maintained to keep the machine full and operating at peak efficiency.
Automation prepares the system for self-cleaning cycles to prevent screen blinding.
Powerful pumps are needed to move the refined paste to the evaporation plant. We now enter the heart of the factory, where water is removed to create the concentrate. This multi-stage system will reduce the water content, thickening the paste into a rich concentrate. The process begins in the plate heat exchanger, where the surface area is maximized for rapid heating. Thin layers of paste pass against layers of steam, raising the temperature instantly. By operating under a vacuum, we boil off water at low temperatures to preserve the flavor. The water vapor is extracted and condensed, leaving a thicker product behind. As the liquid thickens, forced circulation pumps are required to prevent it from burning on the tubes. High velocity keeps the heating surfaces clean, scrubbing away potential deposits. Once the viscosity becomes too high for standard circulation, we switch to the final stage.
The scraped surface evaporator is designed specifically for sticky, high-density concentrates.
Internal blades continuously scrape the heated walls, ensuring efficient heat transfer without fouling.
Here, the product reaches its maximum thickness, concentrating the solids to the target level.
Continuous digital monitoring ensures the concentration hits the exact commercial standard. The water removed is recovered, leaving behind a pure, intense tamarind concentrate.
Only positive displacement pumps can move this dense material without cavitation.
The physical consistency is now that of a heavy paste, rich and dark.
Before packaging,
the concentrate must undergo a final thermal treatment to ensure shelf stability.
To heat the concentrate above boiling without evaporation, we must first increase the system pressure.
Inside this closed loop, the paste is subjected to intense thermal treatment.
Superheated steam surrounds the product tube, driving the temperature upward rapidly. At 103 degrees Celsius, any remaining spoilage organisms are effectively neutralized. The immense pressure prevents the moisture from boiling, keeping the paste in a liquid state. Time is just as important as temperature, and the product must be held here to guarantee sterility. Automated safeguards will instantly reject any product that fails to meet the thermal standard.
Immediately after sterilization, the paste enters the cooling cycle to preserve color and flavor.
Shock cooling halts the cooking process, locking in the tamarind's natural acidity profile. Every connection is steam traced to prevent microscopic contaminants from entering the sterile zone. We maintain positive pressure to ensure that any leak would push product out rather than letting air in. This sterile buffer tank holds the product briefly before the final packaging stage. The paste is now a commercially sterile, shelf-stable concentrate. We now transfer the finished product to the most critical area of the facility. In this clean room, the product will finally meet its packaging. Inside the filling zone, the air is filtered to hospital-grade standards to protect the product. Human contact is minimized, and strict sanitation protocols are enforced at every step.
We use high-barrier aseptic bags to protect the concentrate from light and oxygen.
The filling head creates a hermetic seal with the bag before opening it. A localized steam flush sterilizes the connection point, ensuring no bacteria can enter during the transfer. The bag is opened, filled, and resealed entirely within a sterile vacuum environment.
The viscous paste fills the liner, displacing the void with high-density product. Automated load cells cut the flow at the exact weight to ensure trade compliance.
Once sealed, the product is completely isolated from the outside world. Physical protection is added to shield the flexible bag during transport. Traceability data is attached to every unit, linking it back to the specific harvest and processing time. 4 drums make a pallet, creating nearly a ton of finished product.
The load is stabilized, ready for the long journey to global markets.
From the filling room, the product moves to the final quarantine and storage area. The manufacturing process is complete. Now begins the logistics phase. The warehouse serves as a massive buffer, holding the concentrate until global orders are received. Precision stacking allows the facility to maximize vertical space without compromising safety.
Every drum is digitally mapped, ensuring first-in, first-out logistics management.
Ambient temperatures are kept stable to prevent condensation or spoilage within the drums.
Reference samples are kept for the shelf life duration to guarantee quality assurance. When an export order is finalized, the logistics team springs into action. the shipment is staged and inspected one last time before leaving the facility.
The link between the factory and the global supply chain is established.
Space is optimized to transport the maximum weight of product efficiently.
Thousands of liters of concentrated flavor are now ready for the voyage.
This facility operates as a living organism, turning raw harvest into industrial value. Sealed and secured, the product leaves our care and enters the market.
The cycle is complete, making room for the next harvest arriving at the gate.
And this is how modern factories produce concentrated paste from raw tamarind pods, from start to finish.